Okay, so if you're running a big venue, maybe a corporate campus, command center, or, that huge sports bar everyone goes to, you know what information overload feels like.
Oh, absolutely. It's not just the screens, it's managing all the connections.
Right. All the hardware you used to need to push dozens of video signals to, well, dozens of TVs.
Exactly. For years, the answer was always the traditional matrix switcher. Think of this giant central box.
Right, like a big telephone switchboard, but for video?
Kind of.
Mm-hmm.
And if you needed, say, 16 inputs and 32 outputs, you bought a massive, specialized 16 by 32 box.
And if you needed 33 outputs later.
You often had to rip the whole thing out and start over. Super expensive, totally rigid, and honestly, a single point of failure waiting to happen.
This is like a massive headache. So today, we're going to dig into something designed to, well, get rid of that pain point. We're looking at the WolfPack 4K 30Hz AV-over-IP matrix switchers.
Yep. We've got the product documentation here from this company. They've been around 24 years, apparently, supplying AV gear globally.
Our mission is to figure out how this specific tech handles scaling video up to, 80 TVs? And how it uses hardware you probably already have.
It's really about that shift, isn't it? From proprietary boxes to using standard networks, AV over IP, using power over Ethernet, PoE technology.
And right away, the accessibility seems different. The starting price they list is $250 for a single unit, a transceiver, or a build-your-own kit.
Yeah, that's a tiny fraction of what even a small traditional matrix system would set you back. Huge difference right out of the gate.
Okay, so let's get into the tech. How does it make this scale and affordability work? We're talking 4K distribution, so bandwidth must be key. It handles 4K at 30 Hz resolution.
Correct, and the compression they're using is H.265.
H.265, why is that important?
Well, that choice is, I think, central to the whole value proposition. H.265 is really efficient at compressing video, and that efficiency is what lets them push 4K video over a standard 1 gigabit Ethernet switch.
Oh, okay. And sticking to 1G, that's the big cost saver.
Absolutely. It's all about leveraging existing infrastructure. See, if this needed 4K at 60 Hz, you'd probably need 10 gigabit connections everywhere.
Which means new, much more expensive switches.
Exactly. You'd be talking major upgrades, replacing potentially dozens of switches across a campus or building with specialized 10G, maybe even 40G core switches. Big money.
So by sticking to 4K 30 Hz and using H.265, they keep it within the capability of the standard 1G PoE network that, well, most businesses already have installed.
Right. It dramatically lowers the barrier to entry and the total cost.
So the 30 Hz isn't really a limitation. It's more of a strategic choice for cost and compatibility. Makes sense.
Precisely.
The docs also mention some key compliance points. HDCP compliant, which you definitely need for commercial stuff like movies or sports.
Non-negotiable, yeah.
And it also says SEC security compliance. What does that really mean in this context?
That's actually quite significant, especially for certain users. Think financial institutions, maybe government command centers, or large corporations worried about network security. It means the system's designed to meet pretty strict standards for network integrity, preventing unauthorized access or data leakage. It's not just marketing fluff. It provides an extra layer of assurance for sensitive environments.
Got it. Now, something else that jumped out at me was the hardware itself. You mentioned transceivers earlier. The docs say the transmitter, the TX unit that plugs into your source, and the receiver, the RX unit behind the TV, they're actually the same physical box.
Yes. That's a really smart bit of logistical design.
How does that work then?
You just use software to tell the box whether to act as an input, a TX, or an output in RX.
Okay, wow. So think about managing inventory for a huge place.
Exactly. You don't need two different part numbers, two bins in the stockroom, different training for technicians.
If one fails, you just grab another one off the shelf, configure it in software, and you're back up.
It makes ordering, stocking, troubleshooting just so much simpler, especially when you're dealing with potentially hundreds of these across a large deployment.
That simplicity must help with the scaling. They talk about supporting up to 80 TVs. There's an example configuration. 14 sources, 32 screens.
The 14 by 32 system, yeah. And they mention running that whole setup off a standard 48-port PoE Ethernet switch.
So this is where that AV over IP approach really shines compared to the old fixed matrix boxes.
Totally. They make some pretty bold claims like unlimited sources, unlimited HDMI ins and outs, unlimited field upgradable.
Unlimited sounds. Ambitious. How does that work in practice?
Well, because the video is just data on a standard network, You're not limited by the number of physical ports on one central chassis anymore. You scale by adding more network switches.
So if I have that 48-port switch and suddenly need 60 screens instead of 32.
You just add another standard PoE switch to your network, connect the new receiver units, and the system recognizes them. You cascade the switches.
The bottleneck isn't some proprietary AV box, it's just standard network design.
Exactly. It becomes an IT networking challenge, which IT teams already understand, rather than a specialized AV problem.
And you mentioned performance. Latency is always a concern, especially for live stuff. The spec says 80 milliseconds for switching and latency.
Yep, 80 milliseconds. And the signal reaches up to 450 feet using standard CT6 cable.
Okay, 80 milliseconds. For, say, live sports or a command center feed. Is that noticeable? How does it compare?
That's a fair question. Traditional dedicated matrix switchers, the really high-end ones, can be virtually zero latency. Maybe under 5 meters.
So 80 meters is a trade-off.
It is. It's sort of the inherent cost of doing the compression and using these standard 1G switches and network protocols. However, for most human perception, in places like sports bars, lobbies, classrooms, 80 meters is generally considered acceptable. You probably wouldn't notice it watching a game.
Okay.
The key thing they emphasize is that the switching itself is fast and reliable across that whole 450-foot distance. The delay is consistent, not variable, which is important. So you trade that ultra-low latency for huge gains in scale, flexibility, and cost reduction.
Makes sense. All right, let's shift from the hardware to the control side. The core idea is any in to any out any way you want. Since it's software defined, that's where the magic happens, right?
Absolutely. The hardware's simple, which means the software has to be robust. And they seem to cover the bases for control. There are iOS and Android apps, PC control software, specific Windows support, even general Wi-Fi apps mentioned.
So whatever device your facility manager or, the bar manager uses, they can control the system.
Looks that way. Ensures accessibility.
But the feature that really stood out to me, the thing that sounds like a game changer for actually using this system day to day, is the iPad real-time video preview on all sources.
Oh yeah, that's huge. Imagine you're trying to manage, say, 30 or 40 different feeds going to 80 screens.
Total chaos potential.
Right. You can't just rely on memory or a scribbled note saying input 7 is ESPN. Having that little live thumbnail video of every single source right there on your iPad control screen, that's critical.
You see what's playing before you send it somewhere? Minimizes mistakes.
Instantly simplifies complex routing. You just tap the picture of the source you want, tap the screen you want it on, done. It makes managing large systems way less error-prone.
And speaking of large systems, it's clearly built for more than just simple switching. They mention support for multiple video walls, any size, any quantity.
Correct. And you don't necessarily need separate dedicated video wall processors, which can be expensive. The receiver units at the screens handle the scaling and tiling for the wall.
So the intelligence is distributed out to the endpoints.
Exactly. And it's not just video. They also highlight support for unlimited computers, USB and KVM control. Specifies 3 USB ports are available on the units and separate audio outputs.
Okay, KVM means I could potentially control a computer located somewhere else through this system.
Yeah, keyboard, video, mouse extension over the network. Useful for remote management or accessing PCs that aren't physically near the display.
And the separate audio outs, why is that important?
That allows for audio zoning. You could send the video from a game to all the TVs in a bar, but send the game's audio only to the speakers in the main bar area while playing background music in a separate dining section, even though the video source is the same. Gives you independent control over sound.
Very flexible. Okay, that integrated control brings us back to cost, especially long-term cost. Before we look at that sports bar package, we have to mention this. No monthly license fees.
Yes. That is a really big deal in the world of enterprise software and networking gear.
How so?
Well, often you buy the hardware, but then you're hit with ongoing annual subscription fees for the software, for support, for licenses per device. It can add up incredibly fast, especially for large systems.
A hidden cost that keeps costing.
Exactly. So projecting the total cost of ownership over, say, 5 or 10 years for a system managing 80 screens, eliminating those recurring fees can save tens of thousands of dollars. For a university, a corporation, that's real budget relief. It's a major differentiator.
It's the difference between a capital expense you plan for once and an operating expense that eats into your budget every single year.
Spot on.
Okay, now let's look at this optional sports bar system they detail. This seems to show how far the software integration can go.
Right, this package builds on the core AV over IP stuff, but adds direct control of third-party devices right into the iPad interface.
Specifically, it mentions changing channels for DirecTV, DISH, cable boxes, even Roku.
Yeah, seamlessly. So the control system isn't just switching HDMI inputs anymore.
So if the manager wants the Seahawks game on TV 15, they don't figure out, okay, that's DirecTV box number 3 on HDMI input 5, now I need the DirecTV remote.
Exactly. The system translates a simple command like put NFL Sunday Ticket channel 710 on TV 15 into selecting the right source box, sending the correct infrared or IP channel commands to that box, and wrapping the video, all from one interface.
That sounds incredibly powerful for a complex environment like a sports bar.
It creates what they call a truly holistic management experience. You can send any channel to any TV, see the actual TV listings on the iPad, control audio zones.
And this part was fascinating. Show the entire floor plan on the control tablet.
Yeah, that's brilliant for usability. Instead of trying to remember which abstract number TV 17 corresponds to in a busy, dim room.
You just look at the map of the bar on your iPad, tap the icon for the TV in the corner booth,
and make the change visually. It takes the guesswork out of managing dozens of screens spread across a physical space, transforms the iPad from just a remote into a full facility control dashboard.
Very cool. And they do remind people that if the standard packages or the sports bar option don't quite fit, you can use the build your own approach with the individual transceivers or get a custom quote.
Which goes back to that modularity. Starting from that $250 unit and scaling up with standard, off-the-shelf Ethernet gear, that really feels like the direction things are heading for large-scale AV.
So wrapping this up, what's the big picture for you, the listener? We've looked at this WolfPack system, and it seems to be a really flexible, scalable way to distribute AV that ditches the old proprietary matrix idea.
Yeah, it leans heavily on standard network gear, uses efficient H.265 compression over common 1G networks.
Which enables that big scale, up to 80 TVs mentioned with that 80 meters latency as a deliberate trade-off for cost savings.
And critically, it's all tied together with powerful software control. That iPad preview, the integrated channel changing, the floor plan view, that's where the user experience really comes together.
The core takeaway, I think, is seeing this convergence in action. IT infrastructure, your standard network switches and cables, meeting specialized AV needs.
Absolutely. This shows how a single, software-controlled network, this AV-over-IP approach, can potentially handle everything. Video walls, KVM, audio zones, even changing the channel in the cable box.
All using the Ethernet wiring you likely already have, without needing special AV cables everywhere, and crucially, without those ongoing subscription fees.
That's the value proposition.
So, the final thought to leave you with is this. Look at your own operation. How many different systems are you juggling right now? Separate controllers, maybe an old matrix switcher, audio mixers, stacks of remote controls.
Yeah, how many distinct pieces of hardware and software.
Could all that complexity, all that potentially aging infrastructure, and maybe those hidden ongoing costs, could it all be consolidated onto one common software-defined network? This deep dive suggests that unification isn't just a future idea, it seems to be very much here and available.